when I say find the zeros, I could also say roots. Zeros and roots, they both mean the same thing. What do they actually mean? What's the more standard term? You guys know? If you don't know, I'm not sure how you did part B. X-intercepts. So we call them the zeros because they are what makes the function zero. We call them roots because if you look at the x-axis like the ground, that's where the roots start for plants, right? I know, math people were strange. So what are the x-intercepts? Yeah, -5, 0. I think somebody said 0, 0, and 2, 0. And what about the y-intercept? 0, 0, yeah. If you see a 0, 0 x-intercept, there's got to be 0, 0 y-intercept. Okay. I like it. So for -5, 0, all right, what about 0, 0? 0, 0. What's its multiplicity? 2, which means what's it going to do? It can only do one of two things. Is it going to turn or go through? Turn. What about -5, 0? What's the multiplicity? 1. So it's going to do what? Go through. And then 2, 0, the multiplicity is 1. So again, it's going to go through. Right? And again, you guys, everybody, hopefully, right? There's the multiplicity 2, multiplicity 1, multiplicity 1. Even multiplicities, it's going to do like a parabola. It's going to turn. Odd multiplicities, it's going to do like a cubic and go through. And now we have enough information to graph this to a certain degree. So let's plot the x-intercepts first, and then I got to figure out the y scale. We're going to be a little more precise with this, so that's why I want to do part D with you. So I can go ahead and let's just make the x scale the good old 1, 2, 3, 4, 5. Because none of my x-intercepts are that freaky. -5, 2, and 0, 0. Now here's where we can be better. Did I actually not even, what was the end behavior? I sort of skipped that by. And the nice thing with it, when it's not factored, it's really easy to tell what the degree is. What's the degree of the polynomial? 4th degree. So then what's the end behavior going to be? Yeah, it's going to go up both sides because it's not negative, right? So what does that mean for me? X-intercepts, relatively easy. Even if I have to factor it, it's really easy to see what they are once I factor it. And then the end behavior tells me I'm going to start up here, right? It's got to be up on both sides. So I know I'm going to start up here. And then I'm not going to draw anything yet. So I'm going to go through -5. I'm going to have to turn around and I'm going to come back to 0, and then I'm going to turn. And then I'm going to come back up and go through 2. So I need to know, wouldn't it be good to know how deep this goes? Like, does it go, or does it go, whoa? So how in the world would I figure out roughly how deep this is? Do you guys understand what I'm saying? How far down? It's got to go through -5. How far down does it go before it comes back up? What can I do? Yeah, okay, cool. Plug in something in between. So let's plug -2 in. And that's what I mean by at a few more points. So what is f of -2? Let's see. It's sometimes easier to even use this. It'd be f of -2 would be 4 times 3 times -4. Is that cool? F of -2? -2 squared is 4. -2 plus 5 is 3. And then -2 minus 2 is -4. So what's that? No? 12 times -4? -48. Are you guys right? I just plugged a -2 in. You can plug it into this guy too, of course. They're both the same function, yes? So when I plug a -2 in, I get a -48. Oh shit. Now, what else would be good to plug in? So now I kind of know relatively how deep this is. What else would be good to plug in? I know how deep this is roughly. 1. If I plug 1 in, I know how tall this is. Is it tall and skinny, or is it like really, really flat? So let's see what we get when I plug a 1 in. I get 1 times 6 times -1. I get -6. 1 squared is 1. 1 plus 5 is 6. 1 times 6. 1 minus 2 is -1. -6. And again, you can plug it into this guy too. Doesn't matter. So I know f of 1 is -6, and f of -2 is -48. So what's a good y scale to use then, considering I need to be able to go down to 48? 6 is not quite, because I need like 8 tick marks to get to 48. 12 sounds promising. And again, you don't have to use 12. You just have to make sure that you can get to 48. So if I use 12, -12, -24, -36, -48, -60. I made it to -48, right? So it's f of -2 is -48, and f of 1 is -6. And that's going to be halfway right there. Now, do you think it goes like this, or do you think it more likely goes like this? Do you see how that just kind of fills itself in now? Maybe. Now, that's still not great. I probably should have plugged in f of -3, but it doesn't matter. You just need something to at least give me some idea that you understand what other points might help you, right? Now, what really sucks is if the work you did does not match the picture you make because you copied the picture out of your calculator, right? That's the worst thing. That's going to guarantee you lose the most points. I would much rather you lose some points because you did some work wrong, but you actually graph according to that incorrect work. Does that make any sense? Because part of what I'm testing on is doing the work and then translating the work you did into a graph. So I'd much rather the graph be wrong too. That's actually better because you translated your work correctly, the work was wrong. And so one of the worst things I see is this. You ready? I see somebody do this. I'm going to just do it kind of quickly. Look at this. That tells me immediately that you got it out of your graphing calculator and you didn't make your window good. Do you see? I mean, does that make any sense? But isn't that what you would see in your graphing calculator if you didn't look far enough down? Wouldn't it just do that? Because you can't even see where it turns, right? And I see this all the time. I'm like, oh my God, make it harder on me. Or just don't copy from your graphing calculator, right? Okay. Let's see. Let's see what we can do on the back here. Oh, it's even more washed out. I'm sorry. My poor little printer. Oh. Can you guys see that one? You probably can't see it at all up here. Yeah, holy crap. You write that again. I can't even see it well enough. Plus 3x squared. Is that a plus 9x minus 27? Is that what it is? I think so. Yes. Okay. Now let's see. Let's do this together.
There's a negative at the beginning.
Oh, thank you. Finally, Jeff. Thank you, Raleigh. Totally missed that. Okay. Finally give us one that's negative. What's that going to change then? What's that going to affect directly? And behavior. I love it. So it's not going to be like a standard cube. It just flips. It's a transformation. It just flips. That's all it does. So, of course, the degree is 3. The end behavior is going to be like this now. And when I ask you end behavior, this is all you have to do. This is all you have to show me. Okay, I might show you, I don't want to bring in too much weird notation yet, but I am eventually going to show you some notation that goes along with this, that you might see in the book. But right now I just want to stay just with the concepts before I start bringing in weird notation. Right? So this is really at the moment all I need to see when I ask you what the end behavior is. How do I factor this weird dude? How many terms are there? 4. So what do I do when I see 4 terms? Grouping. Yeah. Grouping. Now we got to be kind of smart about this. That negative out there is going to screw us up. So what can I take out of these 2 things? Good. How many x's? 2. So what's left? Let's see, I had 3x, I had a negative, took it. I had 3 x's, took 2 of them, so now I just have 1. Is everybody cool with that? Just GCF here, right? Yeah, and this is it was positive, I divided out a negative, so it's negative. And I had 2 x's and I took them, so I just have a 3 left. So each term just changed signs and lost 2 x's, because that's what I took out. What can come out of these two? 9. And when I do that, thankfully, I'm left with, what do I see that tells me I'm on the right track, that I can actually do the next step? What part of that tells me I can do the next step? They're both the same, right? Don't do the next step if that one is x minus 3 and the other is x plus 3. You made a mistake. You can't do the next step because the next step says take out what's common. And what do both of those things have in common? X minus 3. Let me write this like this. Okay. Is that cool? Because the 9 is positive, x squared is negative. You guys cool? Am I done factoring? That's a good answer. Well, no, just cut it in half, right? Doesn't matter who's where, right? So this is just the squares. So 9 becomes 3 and 3. X squared is x and x, plus minus. All right, let me stop for a minute. Is that? I don't care if it's the squares, I don't care where things are. I just cut them in half where they stand. What are my x-intercepts? What are my zeros? Something a little weird here, but not too bad.
3 and -3.
Yeah, one's 3 and the other one's -3, because 3 happens twice, right? Maybe? No, watch, let me write this even a little bit better. Can't I take a negative out of this? Aren't these the same thing now? So then it's a little easier for the next step, because I can see the multiplicity better, right? Because 3 occurred twice, so I should be able to consolidate where it comes from. So if I take a negative out, this becomes the same as this, and I can just consolidate them. So what's the multiplicity of 3, 0? Which term did it come from? Which term gave us 3? This one. So what's the multiplicity? What's the power on that piece? 2. It's the second, it's a multiplicity of 2. And that means what's it going to do? Turn or go through? Turn. And what about, sorry? Yes?
How do you know if it turns or if it's
Okay. This piece by itself, if I took that away, what shape would this be by itself if I graphed it? Parabola. So at 3, it looks like a parabola. It's going to turn at 3. So if the multiplicity, if the power on the term is even, it's going to turn. If the power of the multiplicity, which is also known as the power, is odd, it's going to go through it like a line would go through it. Right? So at the 0, -3, 0, multiplicity, like I just said, is 1, so it's going to go through. What, did I miss? Yeah, what's the y-intercept? I finally gave us a y-intercept. It's easier to look at it from the beginning, right? Can't you just see what the y-intercept is here? 0, -27. Okay. So it looks like the only x-axis stuff I have are these two things, right? So it looks like my x-axis scale can be the nice 1, 2, 3 stuff, right? Obviously, if one of your x-intercepts was -28, you wouldn't want to do a scale of 1. Okay. But in this case, my x-intercepts are 3 and -3. I don't need any funky ass scale. I can plot my x-intercepts. I can plot now my y-intercept is 0, negative 27, but I don't want to make a scale. I don't want to make a scale yet. All this is new. All this is brand new, right? Everything we're doing today is brand new. So you got to let it kind of sink in. But plotting the x-intercepts. Okay, that's beautiful. Now, what's going to tell me, do I come at this point from above or do I come at this point from below? Which one? From above. Because of this, right? I told myself in the beginning, I'm going to start from above. So I'm going to come at it like, I'm not drawing anything yet. So I'm going to come at it like this, and I'm going to go through, yes? Mm-hmm. Go through, and then I've got to turn somewhere here so that I come back here, and then I can do it. So the y-intercept is in between those two already. So I really just need, so I'm coming down, go through this, I'm going to go through the y-axis at some point, and then I'm going to turn at 3. And that's going to match up with my end behavior then, correct? Okay. There are a lot of moving parts, but you don't have to think about all of them at once. So I really don't need another point. What scale can I make to fit this guy in? Say again? Okay. Negative 9, negative 18, negative 27. Bam. So then it's coming in like this, goes through here, and then it turns here. And let's verify that real quick here. Let's see what this looks like. Shoot. Hold on, everybody. Negative x cubed plus 3x squared plus 9x plus 27. Oh, shit. Okay. There we go. Ooh, it looks nice. Bam. Bam! Look at that. Isn't that basically what we had? Maybe. By the way, real quick on Desmos, if you want to change the x, see this little wrench up here? You can change the x-axis and the y-axis. Sort of like the x-min, x-max, y-min, y-max in the calculator. You can just change it right there if you want to be able to pull it like this so you can see things better. Yes? No? Okay. It's up to you. You don't have to use Desmos, but it's awesome. It's out there. Okay. So, considering that factoring is so crucial to these things, let's take a minute and look at this. Oh shit. Let's actually look at it, Jeff. Bam. So I just gave you all this here, right? And I know this is very but again, quick reference guide at the top, and then explanations of each down here, right? Okay. So let's do some of these. Try to do the first, I'll tell you what, try to do number 1 and number 3. Those are definitely two things we've talked about very recently. And then we'll look at number 2 together. Does everybody have one of these sheets? I think I gave. Yeah? Oh, you put them back there. All right, this should be, number 1 has to be quick, right? Just has to be. What does that come out to be? Yeah, just cut x in half, cut x in half, cut 81 in half, cut bam. And when I say cut it in half, I mean multiplicatively, right? because FOILing is multiplying. Okay. Real quick, all right. I want to show you a couple things. Watch this. A couple of little extra things about squares. Can you factor this? Yes, you ready? Half of x squared, half of 2, plus minus. Maybe? Maybe? Now normally, when you're, especially in algebra, when you said factor, you were talking about factoring using rational numbers. But we can extend the things we're doing to include irrational numbers. We can extend them to include freaking complex numbers. Yeah, Jeff, I want to do that. Okay. What about this? Now, I always get somebody telling me that the answer is this. Why is the answer not this? How can you tell really quickly that the answer can't be that? Because you get a middle term, don't you? Yeah, you get the 4x in the middle. It doesn't have a 4x in the middle. And so if you make them both minus, now it gets negative 4x. Ah, shit. But, watch this. Oh, shit. Don't the middle terms cancel?
Yeah.
And you get x squared here, correct? And then you get minus 4i squared. What's I squared? What's I squared? Negative 1, so you get x squared plus 4, sure enough. So these sums of squares, I cannot factor them using real numbers. I cannot. Complex numbers are cool with it. They can work. Why do they work? Because they're the only numbers that when I square them, they could come out negative. Right? Real numbers can't do that. Maybe? So real quick. How do you factor x squared plus 9? Yes. Okay, maybe. Okay. So that's just a little pushing the envelope with what we can do with squares. So we're getting a little more sophisticated in our capabilities. We might as well just go, real numbers are not the only numbers out there, so. What about this one? This is the one you just have to kind of memorize, which is why people hate it, and I don't blame you that much, but little dude, big dude, right? I think we basically did exactly this one earlier, didn't we?
Yeah, we did.
Just with an X instead of an A. So it's one A and one 2 with a plus. The other two A's, the other two 2's with a minus in the middle. So one of each, two of each, product in the middle.
Does it become minus 1 plus I
Oh, if you, yeah, this is not an equation, correct?
Yeah.
I don't know if this is equal to 0. I don't know what it's equal to. So this I have to stop here. If it was equal to 0, sure. Okay. But be really careful. If I just want you to factor, don't set it equal to 0. You don't know what that equals, right? I don't know what it equals. So, yeah, but good point. I like it. All right, now number 2. Who remembers what the shit to do with number 2? Why does number 2 suck? Because if that 8 wasn't there, it would at least be easier to look at. But who remembers if there's a number that's not 1 there, what's the first thing I need to do? Take it into account, right? 8 times 9 is 72. It's all good. So I need numbers that multiply to be 72, but add to be negative 38.
negative 36 and negative 2.
Yeah, negative 36 and negative 2. I love it. So what do I use? What do I do with those? Always imagine somebody's like, I'll tell you what to do with those. No. How do I use these numbers? What do I do? Anyone remember? I take the minus 38 and I break it up into minus 36x, minus 2x. Just whatever these are. And it doesn't matter who you put first. Because now what have I done? What have I done? I've made it into 4 terms, and what can I do when I have 4 terms? Grouping. This step here, am I looking at the right place? Yes. This step right there tells me the only numbers that I can break 38 up into so that the grouping will work. That's what that step does. So what comes out of these first two?
X squared minus 36X.
What? What comes out of these first two?
Oh, and 8X.
No? Does 8 go into 36?
Four.
Yeah, so 4 goes into 8 and 36, and I can take one x out. So I took an x, and 8 divided by 4 is 2. I took an x away, and 36 divided by 4 is 9. Now what can I take out of these two?
Negative.
Yeah, negative 1. So then that becomes positive 2x, and then 9 becomes minus 9. And what tells me I'm on the right track? These are the same. So then the last step is, since those are the same, I can take them out, and if I take them out, I'm left with 4x, holy shit, I'm left with 4x minus 1. Kabam. Now if you have another way to factor this, you might want to show it to me before you just do it, because there is one way that I will not allow you to use unless you can explain to me why it works. Right, and that's that one where you just take these numbers and divide by the first number and reduce and I'll do all this funky shit. If you don't know why that works, I'm not going to let you use it. Okay, maybe. All right, let's try, yeah, that's fine. We might do a few more of these, or if you want to try some of these out, if I think about it, I can make an answer key for this. But again, it's really, really important that you are feeling comfortable with factoring, because it's going to become very prevalent in this next chapter here. So don't forget, quiz tomorrow, 363741. And tomorrow I'll have the practice test, because the next day is going to be a review day for the test. Okay. If you have any questions, just come up and see me.